This tutorial is a getting started tutorial for SavvyUI. SavvyUI is a C++ GUI library for the development of Windows applications. It's available for download from SavvyUI.com. So if you go to your browser and type SavvyUI.com and hit enter, it will get you to this page, and then you're going to click on downloads. And then currently 2 versions of Visual Studio are supported, 2019 and 2022. I'm using 2022 for the purpose of this demonstration. I'm going to be using that version, so I'm going to download the library. This is a full-featured library. It's not missing any features. The only thing it has is a banner that indicates that this is an unlicensed version. It will continue to be there until you pay for a license, but you could go ahead and develop an entire application without any restrictions. And when you're ready to release it, you could purchase a license. The license itself will remove that banner. So we're going to click on download, and we're going to save it in its own separate folder. So I'm going to create a folder on my C drive called SavvyUI. You could name your folder whatever you want, and then just save it there. Once it's downloaded, we're going to go to that folder. I'm going to double click on it, and then I'm going to right click on that one. I use 7-zip to unzip it, so I'm just going to extract it here. You could use whatever unzip utility you have. And then I'm going to delete that file. I don't need it anymore. The library it comes with 3 folders. The include, which has all the header files for all the components and utility classes. Then you have the SavvyUI app VC 2022. This is a template or a boilerplate application. You could use it as is. And then you have the VC 2022 folder, which contains the libraries. You have libraries for all types of compilers, 64-bit, x86, and you have the release and debug versions. So in the boilerplate application, this is already configured application. You could use it as a starting point, or you could just copy it and rename the files to whatever project you want. This gets you up to speed to be able to actually just create an application without having to do all the boilerplate work. Even though it's minimal, it takes care of the configuration and all that stuff. But in this tutorial, we are not going to use this template. We're going to build it from scratch. So we're going to create a new application. We're going to configure it just to show how it can actually be configured from scratch. And then we're going to create our main window and then start adding more more features to that application. This demonstration is going to be limited to getting started. That means we're just going to basically create a basic project, configure it, have a main window, and probably have a few components in the main window. And then that would be it. That's just the getting started part. There will be following videos that will actually go into more details about other types of components, such as modal pop-ups, dialogues, accordion, all these different things. But for now, let's continue with opening the sample application that was included in Visual Studio 2022. And once that opens, you don't have to do anything. It's already been configured, so you can just run it and see what it looks like. And that's what the application looks like. Now, if you look here, it has edit menu, and it also has submenus, edit. It has a title bar, icon, custom icon. It has this button, which is always there, and this actually allows you to switch themes. SavvyUI comes with several themes automatically, so the user, when you distribute the application, the user can just toggle this button to see the theme that they like, and as they're changing themes, the last theme that they pick will automatically be saved, so the next time they start the application, it will start up with that theme. So at this point, we're just going to close this application. As I mentioned, we're not going to use this application template. We're going to start from scratch. So I'm going to close this one, and then I'm going to open a new Visual Studio instance. so I can actually create a new project. So we're going to create a new project, click new project, and you're going to create a Windows desktop application. So if you don't have that, you could always just type it in the search box to find it. And you could choose the language, and it would be right here. You could select it, but I already have it on my recent project, but this is the one you're going to be choosing. So now you click next. Name your project. I'm going to choose, I'm going to put it in the folder where I put the library. So I'm going to go to SavvyUI, and it's going to be placed right here. And we're going to name this our demo. And we're going to choose to place the solution and the project within the same directory. So I'm going to create. So if you notice here, the project will be created in C SavvyUI our demo. Excuse me. So this is how Windows creates the application, and it has boilerplate code that if you run this, it will display the normal Windows application, but we don't need any of this stuff using the SavvyUI library. So we're going to delete this code right here. We're just going to leave the main function, and we're just going to return 0 here, and we'll delete all the code below this point. So what you should be left with is just this. So the first thing you have to do is create an instance of frame. The frame class is the main window class. So you only have one instance of that in any application. To create that, you just do class my frame, or whatever you want to call it, and this should inherit from frame. Now the frame class comes from the library, that the SavvyUI library. However, at this point, we haven't configured this new application to give the application visibility to the SavvyUI library. To do that, you're going to go to Project, Our Demo Properties, which is our application. You need to configure it for all debug and release and different types of platforms, 64 and 86. But for now, we're just going to use debug 64. So what you need to do is configure and make sure this matches what you have for your project currently configured. So we're going to click on VC++ directories. You're going to configure the include directories, and that will point, since our application is actually on the same level as the library and the include folders, we're just going to go back one directory for, so our application is actually our demo. So it's going to go up one directory, and it's going to be pointing to this folder. And I'll show you why we need to do that. So now we just have to go and include // and then we also need to include the library directory. The library directory, which is right here, is also going to be going back one directory, but it's also going to add VC 2022 because we want to actually point the library directory to the where the libraries are included. So we're just going to say VC 2022. And now with this, we can point to the library itself that we're going to be using. Since we're using debug 64, we're just going to click on linker, expand that, and then go to input and additional dependencies. You're going to put at semicolon, and what we're going to choose is we're going to choose the debug 64 version of the library, and that would be, if you click on VC22, that would be this one. So we're just going to copy this name and then place it right there. And now when we apply, now our application should have full visibility to the SavvyUI library. Now, if you remember, when we added the include directory, we actually had it point to SavvyUI C SavvyUI instead of C SavvyUI include. So anytime you include any file from the SavvyUI library, you actually have to include the include folder like that, and then whatever class you're going to be using, whatever component. So in this case, now we actually resolved the frame, and the frame has several functions that you could implement, but one of the most important functions is the onConstruct panel. And that, if you go back and look at the boilerplate application that was included, and you open that file right there, you could always go back and copy code from the template to. So we're gonna just copy these two for now, and we're gonna place them in our application, in our frame class. And instead, let's rename this as, instead of my frame, main frame. So now we have the proper constructor. We're going to make this public. And what the constructor does internally, it's setting the theme to dark theme by default, but we don't need to do that. If you just choose to make it as a default, then you could. But for now, we're going to remove that. You also can set your license. We talked about the license being needed to actually remove the banner that indicates that the software is unlicensed. When you purchase the software, you will be sent a string. It's an encrypted string that you could just replace this content with, and then that will remove the banner. The function that needs to be implemented and has to be implemented is on construct window, and this function gets called when the frame becomes active. So when you run the application, this is the first function that that framework calls for you to create your main window and set up its content and all that stuff. So this will make the window centered. And then we're going to remove all this code right now. And just make it look like that. Now, we also need to instantiate the mainframe window. We're going to instantiate that from the winMain function. And to do that, I'm just going to go back to that code and just copy these. And we're just going to replace that return 0 with that. And what this does, there's common utils. This is part of the library. It allows you to get the screen size. You could set the size to whatever you want, but this allows you to actually figure out what the screen size is at runtime and set your window size based on that. In this case, this sample actually sets it to the screen size width and height, but if the screen width is greater than 1400, then it uses 1400, and if the height is greater than 800, it uses 800. But you could just always set it to screen width and screen height, or you could set it to whatever numbers, random numbers you want. If you exceed the screen size, if you set a number for the width and height that exceeds the screen width and height, it will automatically be restricted to the screen width and height. Now, you also, if you notice, the mainframe had a constructor that gets past the title of the application. So this title is what appears in the caption bar. So we're just going to remove that, and we're going to call it our demo instead. And then once you instantiate the instance of mainframe, all you have to do is just call show on that instance and basically set the dimensions of it. The dimensions are coming from this bound rectangle that we set up based on the screen size that we got. And if we try to build now, we're probably going to get an error because UI common utils is probably not included. Oh, I'm glad we got this. So this is because we're building debug. We need to go to the project properties and we'll click on C++, and we're going to click on the code generation, and we're just going to change this to be static, and we're going to choose multi-threaded debug as static, and we're going to apply that. The reason why you need to change the runtime library, because if the other option was choosing a DLL, you're linking statically to this library, so we're going to choose the static version of the runtime library. Now when we apply, click that, now we build. And as you can see, everything got resolved. If we try to run this application, Control F5, there you go. And we'll leave it at this for now. So now we're going to go back and construct the windows. Now we have a blank window. So what we're going to do is we're going to use something called a grid panel or a grid layout. And by default, the frame and the dialog, they actually have a grid layout content pane embedded in it. So what we're going to do, we're just going to retrieve that. So the way you do that is you declare an instance of that, a pointer to a content pane, for example. We're going to call it content pane. And we're going to set that to, we're going to call get content pane, which is a function of the frame. And that gives us a handle to that. So all we do is just check to make sure that we actually got a valid one. And if you have that, the first step to do is to set your layout for the content. So the layout is actually an array of, if there is a set layout function, which we'll type right here, and it has two parameters. It has a list of columns and it has a list of rows. So basically you're building a grid. So you specify how many columns and the dimensions of each column and how many rows and the dimensions of each row. Now, any value that you put, you specify from 0 and up, that will be taken literally, and that's what what will be allocated. So if you specify a column of 100 pixels, that's what that column is going to be basically set. I'm talking about grid column, basically. So the screen is going to be divided into that many columns with those different dimensions that you specify. So, and then you could choose -1 if you want a fill column, meaning a fill column basically what the layout does, it adds up all the fixed column values, and whatever is remaining from the screen from that sum, so it subtract that from the screen width, and then it allocates the remaining to the fill column. So if you have one fill column, that column will get all the remaining space. If you have two, that remaining space will be divided into two, and so on. So to do that, we're just going to do we'll create a frame that has a left side menu, and on the right side, we're going to make the left side menu be 300 pixels, and then on the right side, we're going to have a card panel. A card panel allows you to store many panels inside it and just basically make one visible at a time, very similar to a tab, but it doesn't have the tabs. You do that, you flip the views programmatically. So the layout that I described will have 300 fixed for the left side menu, and then we're going to have -1 for the remaining space on the right side. And then this was for the columns. Now for the rows, we're going to have just one row. The left side menu is going to basically occupy the entire height, and the right side card panel is going to occupy the entire height. In that case, we just have one row, which is -1. And that means it occupies the whole screen. Now we could actually add components to the content pane. We set the layout. Now we only have to add components and specify the column and row that they occupy. I mentioned we're going to add a menu on the left side, so I'm going to use a component from the SavvyUI library that called the button menu. And that button menu can actually be, has two modes. It can display buttons or it can display links. So we're going to declare it first, and we're going to call it button menu. And then we're going to declare a card panel. And that one will be, we're going to call it card panel. we just have to include the proper headers for those two. So we're gonna take this, copy it, paste it right there. Take this one, copy it, and paste it right there. So now these have been resolved. Now, if to add these to the view, all we have to do is just say content pane, add component, and we're gonna pass the address of the button menu. And then we want it to be at column 0 and row 0. So we do that, 0, and that's it for that one. And now we're going to add the card panel. Going to copy that. And the card panel is going to be column 1. So 0, 1. But the row number will still be 0. So now if I run like this is what the screen is going to look like. So this is the button menu, and there's that card panel. You don't see it because it doesn't have any child panels in it yet, and this hasn't been initialized. So we're going to initialize this menu to add few items. So I'm going to close this window again. And to do that, we're just going to, let's create a function to organize our code better. So we're going to call it init components. And there's going to be a function of frame, so init components. And we're going to initialize the button menu. Dot. We can set a title to that. You could call it if you want. If you want a title, you can have a title. And we're just going to say menu. And then we're going to add item. And this item is going to have a text that gets displayed, an ID. You don't have to have an ID, and you could also have an icon if you want for the item, but we're just going to add text. So we're going to add, eventually we're going to add 2 panels to child panels to card panels, so we could just show how the panel can flip views between the two. So let's add, we're going to add, let me see what components we have there. So going back to the header that includes, we could add a button grid, for example. That's one, just for the demonstration. And we could also add a tab pane, or we could add a tree view. So we're going to add tree view and a grid panel. So going back to that, now we're going to say a grid or button grid, you said, button grid. And then we're also going to add a tree view. Now running like this is what's going to happen. You'll see those as 2 separate buttons. One thing we need to do, because we're going to make this button menu sticky, meaning when something is selected, we want it to continue to be highlighted, not just clicked and then the visual of the selection disappears. So we're just going to say button menu dot set pinnable, and we're going to set that to true. So now when we run that again, we click on it, now it shows selected. Now, we also need to initialize the card panel. But before we do that, we need to create panels, child panels that contain the button grid and the tree view. We're going to create separate files for those, or we could create one file that contains both panels, and I'll show you how to do that. The one thing that we need to do is right now, when you click on these buttons in the button menu, we're not getting the event. What that means is we need to actually register with the button menu as a listener, so that anytime a button is clicked or an item is clicked in that button menu, we get the event, so we can actually do something with that. So in order to do that, the first thing we have to do is actually implement an interface, and that's called Action Listener. If you right-click on that one and go to Declaration, this is the interface. You just copy that. It's declared as an abstract function, so you have to implement it. Anytime you inherit that, you're going to have to implement that function. And this function gets called for many objects, different objects. The button menu, anything that has actions like button grid, button menu, button, checkbox, all those things, they actually need to, they fire action event. So we're gonna, on the button menu object, we're gonna say add action listener. Add selection listener. I'm sorry. So this actually fires selection listener. So instead of action listener, we'll keep that for now, but we need to actually implement the selection change listener. So we're gonna go up here and we're gonna do public selection change listener. And this one, if you go to its declaration, you have to implement this function, which is on selection changed. Now we'll go down here and we'll just add that too. The selection will be passing you these values. The selected value in the case of button menu will be the text of that specific item that was clicked. But we'll deal with that in a moment. So now that we have this, let's just actually deal with it right now. So we're going to say if event.selected value equals, you should basically get whatever the item text is that you added. So we're just going to copy that. And for this one, we're going to do something, and then I'm going to copy that and add it as add an else for that tree view. And for now, we're just going to display a dialog to show what selection we received, just for the demonstration purpose. So dialog factory, and this one, we need to include dialog factory. And now we could call some, it has, dialog factory has a lot of static functions, so you don't have to instantiate that class. You could just use it in a static way, show info, and then each one of these functions will receive a parent. So the parent will be this frame, and you could pass whatever you want there. So we're gonna just enter the EV selected value. It's just to show what value we received. Selection. So if I run this again and I click on button grid, as you can see, we're displaying what we received. So we don't need to display what we received. That was just for demo purpose. What we need to do is actually change the card panel to display the view that we want. In this case, we're going to go back here into the init component, and we're going to add two panels to it. We're going to add a card. One of them we're going to name them exactly the same way as the items, the text in the button menu. So we're going to copy this. And we're going to have to pass a component. So let's pass a grid, button grid component. So we're going to say button grid. It's not resolved yet because we haven't added an instance of that in our declarations. So we're going to copy this again. So the card panel receives a name for each card and the component that you want to display. And that's how you're able to change the cards or flip the cards in the card panel. Basically, you will be calling a card panel.setVisibleCard, and you're going to pass it one of these values to display whatever you want to display. So let's go up and to the top of this class and declare these two components. So we're going to declare a component called button grid with this name, and we're going to declare a tree view. And this will be tree view. And we're just gonna include the file that we need to include for both of them, button grid, tree view. And now we have those. And now, since we already have those resolved, we're gonna remove this dialog factory, and we're gonna say card panel dot set visible card. And we could hard code button grid, or we could just put in this value because we named them the same. So you could just pass that. The same thing for the tree view. We could have done just have one statement and just if we make sure that we always name these the same way we name them in the button menu, then you just have one line which is card panel set visible card ev.select selection value, and that will automatically select whatever view you're supposed to select. So now let's try to see what happens there. If I click on that one, as you notice, there's a border for the grid, button grid, because we haven't added any buttons yet to the button grid. This is what it displays like. Same thing for the tree view. We haven't added any items. So now we're going to go back to the button grid component and set it up with few buttons. So in our init function, we're going to come down here and we're going to do button grid dot add button. And this is very similar to the button menu. You just specify the text that you want for the button. In this case, let's call it button 1. And you could also specify an icon. An icon is an icon source type, so you could just say icon source. And this has several several different types of parameters. You could specify an actual image file, resource ID, or icon type. So we're going to do icon type. This is a built-in library of images that are custom drawn, so you could use any of those. It's included in the library. So let's say we just add add. And let's actually change the name of this button to be add. And let's add another one, and we call it delete. And for this one, we'll just use the delete icon or remove. I'm not sure, I forgot remove. Okay. So now we have that. If we run now and click on the button grid, you see that we have two buttons. Now, if you click on these, nothing will happen. Why? Because we haven't added a listener on the grid panel. This would be a good time to actually do that. But before we do that, I'm going to add a couple more buttons. And let's see what we have. We'll do align bottom. And this one, let's do binocular. And now when we run, we're going to have 4 buttons. If you exceed certain number, then it automatically wraps to the next line and so on. So if I add another button right now, it's probably going to go to the next row. And now we also need to add a listener to this one. So now we do add action listener. This one fires an action listener. And since we already inherited the action listener in this class and we implemented that on action, we're just going to say this. When we receive an action, because a lot of components fire the action event, you need to determine which component actually fired that action, because you're only going to have one implementation of this function. So here what you could do, every event that you get is going to have a source component ID. So if you compare that to your button grid, for example, and each component has a get ID function. So if you compare it and that's true, that means you received this action event from the button grid. And now the button grid, the action event also has action name and action ID. If you specified an action ID when you added the button, then you could use that, or you could use the action name and you compare it to your add, for example, if action name equals add, and you could do whatever you want, or if it's delete or align bottom or whatever, or binocular, any of that stuff. But for now, we're just going to display that to just show that we're actually getting the event. So we're going to do dialog factory, show info, and remember that we have to pass the parent, which is this, and we're just going to pass the event, the action name that we received. And when we run that, if I click on button grid, if I click add, there you go. If I click delete, align button, binocular. Okay, so this component is set up already. Now, if I click on tree view, notice that this view switched to the tree view, but because we haven't added any items to the tree view, it's empty. So if you switch back to button grid and switch back to tree view, it's just you just keep flipping the view in the card panel, and you do that by basically calling set card set visible card on the card panel. Okay, let's initialize the tree view. So we're going to take that tree view right here and we're going to initialize it with some items. So we're going to add item, and we'll add an item called, let's say, root, and that's the text that's going to appear in the tree. And this returns an index for that item that you added. So let's call it index. And now when you add another item, we're going to add a child to the root. So we're going to do tree view dot add another item. And for this one, we're going to pass text. Let's say we'll call it, let's actually call the root C to emulate a drive. And then we'll add Windows folder, for example. And we're not going to have an ID, so we're just going to set it to blank. But it's important to actually set the parent ID. The parent ID is of type string. So it's basically, oh, actually, we're going to do this. We're going to set an ID, and we're going to use that. We don't need the index. So we're going to set this to be C drive. Call it whatever you want to call it. And then we want the C drive to be the ID. Remember that the first one, the C drive, does not have a parent. It has an item ID, which is we're going to be using to basically attach children to this item. So now we're saying, if you look at the third parameter of add item, it's the parent ID. So now we're using this item ID as the parent ID of Windows. So let's add another folder, and we'll call it program files. And the same thing, the parent's going to be the same thing. And now if we add another one, and this one, we're going to call it program files x86. These are standard Windows directories. So now we have a parent and 3 children. So if we run the application and we click on tree view, we have the C drive and we have that. If we click on that, it collapsed. And so let's add a couple of directories to Windows just to demonstrate how we could actually have subchildren too. And if we go, let's assign an ID to Windows, and let's call it Windows folder, for example. This name can be anything. Just you just have to match it when you add children. So we're going to have system, and the parent, this is not going to have, the parent's going to be Windows folder. And then we're going to add system32. And that its parent's going to be a Windows folder. You just have to, it has all white characters, so we have to use the L. So basically, this is how this is going to look in the tree. You have these. It's going to look like this. So if you run the application and you click button grid, you click the tree view, notice how you have system and system32 as children of Windows, and the rest are children of the C drive. We're going to shut down the application. This will conclude our tutorial of the getting started. There will be a follow-up videos on how to, in this video, we demonstrated how to create an application from scratch, how to configure it, how to create a frame a main window layout and add a couple components to it. We used a couple of the critical components like the card panel, which would be used a lot, and the button menu, button grid, and tree view. But we didn't go into handling events for each one of these components that we used. These will be in follow-up videos, but what we have right now is enough for getting started. This at least will get you up to speed and you'll be able to develop applications. Thank you for your patience and thank you for staying with us.